right, so we're going to work through a full example here that will tie together all of the big points that we learned here in section 7.2. We're focused on a large school district where it's known that apparently 80% of all middle school students in the districts are planning to go to college. So we actually know the true proportion value in this problem of 0.8. We're looking for the probability that an SRS of size 125 will give a sample proportion within 7 percentage points of the true value. So we want to know that if we take a sample out of this population where the real answer is 0.8 for the proportion going to college, what is our p-hat value? What's the probability? It's within 7 percentage points of the true value right here. When you're walking through one of these kind of free-form problems, there are 3 steps you're going to want to consider, which are written on your slides as well. Essentially, what we're going to do is our setup step, our work step, and our conclusion step. And in the setup step, there are a couple things we need to do. Any variables we're going to use in the problem, we need to define them. Specifically, we're looking at the sample proportion of kids who are going to go to college from this district right here. So you actually do need to define your variable, and I'm going to let p-hats equal the sample proportion of students in the district who plan to go to college. So you need to define your statistic that we're going to use, which in this case is p-hats. In all of section 7.2, we're focused specifically on p-hats. So it's going to be the sample proportion of students in the district who plan to go to college. All right, so you define the actual statistic that we're going to be using right here. And we also need to define some key characteristics of this statistic. So we're going to need to find the mean of p-hats as well as the standard deviation of p-hats. So this is still in our first step of the 3. So I guess I'll put a number over here to kind of distinguish what's going on. For step 1, we define p-hats. We need to also figure out what the mean and the standard deviation of p-hat are going to be. So we learned earlier in this section that the mean of the sampling distribution of p-hat, that's this symbol right here, mean of the sampling distribution. So sampling distribution, if we took lots of samples, we graphed them, we just learned, it hopefully will be approximately normal. We'll have to check those conditions in a sec. But the mean of the sampling distribution of p-hats is equal to the true parameter value, which in this case we're assuming is 0.8. So the mean of our sampling distribution is going to be 0.8, and we can just do that right off the bat. We also want to find the standard deviation of the sampling distribution, but before we can do that, we have to establish our 10% condition. So mean, you just go straight to it, but for the standard deviation, you have to first establish that the 10% condition is satisfied. So since our sample size of 125, so our sample size is 125, it says this is a large school district. It doesn't say how many kids are in it, but it's reasonable to assume that in a really large school district, 125 is going to be less than 10% of all students. So since n is 125, is less than 10% of students in the large districts. So our sample is less than 10% of all the students. That means we're actually allowed to find our standard deviation. If the 10% condition were not satisfied, we have to do other things to account for that. Something called the finite population correction factor, but we're not going to get into that in this section here. In most problems like this, you can assume that the 10% condition will be satisfied. You do have to say it, though, and actually explicitly put it here like I did. So our 10% condition is going to be satisfied. We can calculate our standard deviation of the sampling distribution of p-hats. In order to do that, that's going to be the formula that we just learned right here, just a nice, convenient little formula that you're going to have on your sheets. Generally, my advice is avoid putting symbols into the formula. Just go straight to the plug-in step right here. So my first part is going to be the p that goes in, but I'm not going to write p here. I'm just going to go straight to putting 0.8, the true population percent who are going to college right here, or want to go to college. And then it's going to be 1 minus p. 1 minus 0.8 is going to be a 0.2. You either write 0.2 or actually write 1 minus 0.8. Dividing by our sample size of 125. And if you actually evaluate that, you should get, I believe, 0.036 or so if you round. So we have our mean, we have our standard deviation of the sampling distribution of p hat right here. One more thing we need to set up in this step, and that is going to be to establish that p hat, its sampling distribution, is approximately normal. In order to do that, you're going to use the large count condition that we just established earlier on in the section. So, since we have to check n times p and n times 1 minus p. So since n times p, and again, you don't have to put the symbols here, you can go straight to the plug-in step. That's going to be 125 times 0.8. That's 100, which is greater than or equal to 10. So I check that n times p is greater than or equal to 10. I also need to check that n times 1 minus p. So that'd be 125 times 0.2, which is 25, I think, is also greater than or equal to 10. That allows us to say that p hats, the sampling distribution of p hats, is approximately, and it's important that you do say approximately here, normal, with mean 0.8 and standard deviation 0.036. So I'm going to erase this so I have room so I don't have to write all the way down here. But I want to highlight several things that I want you to put on your paper as well. Important things to do when you're setting up this first step, your setup for the problem. First of all, defining the variable is going to be really important. So we establish what p hat actually is in words. Afterwards, we find the mean, we find the standard deviation. But before doing the standard deviation, you got to make sure you do your 10% condition. So you need 10% condition. You also need to establish large counts. And then also, so we got our large counts going on right here. Both of these are greater than or equal to 10. Make sure when you talk about the sampling distribution of p hat, you use the word approximately normal. Don't say it's actually normal. That will cost you points on the AP test. It's an approximately normal distribution with these parameters, or with these values right here. So I'm going to go ahead and erase this then so I can go on to the next step. But that is our setup phase for the problem. All right. So having set up the key stuff in the problem, now we're ready to actually do our calculations and find the probability that they're looking for. In this particular problem, so again, we knew that p hat, the distribution, is going to be normal with mean 0.8 and standard deviation 0.036 is what we got. We want to find the probability. So this would be our step 2 right here. We want the probability that our sampling distribution, the value for our sampling distribution, I should say, our sample proportion, is going to be within 7 percentage points of the true value of 0.8. Within 7 percentage points essentially means we're going anywhere from 73%, and we want our sample proportion to be between 73% and that'd be 87%. So within 7 percentage points means we're going from 73 to 87 if we take a random sample. What's the probability our random sample proportion will be somewhere between these two values here? In order to do that, now that we've established that it's approximately normal, the sampling distribution here, we're just going to do something like we do in Chapter 2. You're just going to do a straight up normal Cdf calculation here. So for this problem, we would want to have our quick picture. We have a mean of 0.8 in the middle. We're looking for the probability that we are between 0.73 and 0.87. Forgot to do our standard deviation of 0.036. And then we're looking for the area in the middle right there. So we want to do normal CDF just with our boundaries in between two values. So lower being 8.73, upper will be 0.87. Our mean is what we calculated earlier, the true value of 0.8, and our standard deviation, which we also calculated, was about 0.036. So actually doing that command is going to get you an answer of 0.9482 approximately. All right? So this step, pretty cut and dry. Once you've found your mean and standard deviation, you're just doing review stuff with our normal commands that we've already learned. I'm going to erase this one more time and go for our concluding step here. So we just set up our work, that's step 2. Now that we have our answer right there, we have to actually state our conclusion in context. So for step 3, we just got 0.9482. That tells us that approximately 94.82% of all SRSs, simple random samples, of size 125 will be within 7% of the true proportion of middle schoolers who plan to attend college. So you just restate in context like you guys are pretty used to doing. So that takes us through our entire problem here, all of the important points, setting up the problem, performing calculations, and then concluding in context.